But today we're going to working on simplifying those same type of expressions using either radicals or rational exponents. And some rules that go along with that are relatively simple. Let's say that I had the cube root of x to the 5th power. When I am working with variables, finding or simplifying when it's in a radical form is really easy, because all I need to do is take the index that we talked about yesterday and divide it into the exponent that is presently there inside. So in this case I take 3 into 5, and how many times does 3 go into 5? Once. So I bring an x on the outside of that radical, still have the 3 as the index, and what am I left with when I take 3 into 5? 2, so inside I would have an x to the 2nd. Okay? So if I had the 4th root of x to the 9th, y to the 5th. I take the index into the exponent. So 4 goes into 9 how many times? Twice. So on the outside of the radical I'd have an x to the 2nd. 4 goes into 5 how many times? Once. So I'd have a y to the 1st. The 4th root of what was left over when I took 4 into 9? So I'd have an x to the 1st, and what was left over when I took 4 into 5? That would be simplified. Okay?
So if it goes in there once, you have to put a line above, like as the exponent?
You don't have to, but I just wanted to show you where the one came from.
We did it on the first one and we did it on the second one.
Right. They both mean the same.
Okay.
If we do have
Question? 4 goes into 9 2 times, right? And I'm left over with 1. And 4 went into 5 once with 1 left over. Right? Okay?
So do you not even mess with the thing that's inside, like the V part of it?
Nope. Nope. So let's say that I had this problem. So I have the 3rd root of 27, x to the 5th, y to the 15th, z to the 8th. So first of all, I need to find the cube root of 27. Are there any perfect cubes in 27? Any perfect cubes?
3.
Okay, 3 times 3 times 3 would give you 27, wouldn't it? Remember we talked about that yesterday, that this means a number times itself. So wouldn't 27 have a perfect cube of 3? How many times will 3 go into x to the 5th? So I'd have an x to the 1st. How many are left inside? 2 of them, right? 3 goes into 15 how many times? Is there anything left over? So do I have a y inside the radical? Nope. 3 goes into 8 how many times? Twice. Do I have anything left over? So that radical would be simplified. Okay? So let's look at this one. What's the index if there's no index?
0.
If there's no number in the index, what is it? It's always a 2. If there's no number there, so it's always a 2. So if you want to put a 2 there, put a 2. Okay, because it means square root. And square root is 2, isn't it? Okay? Is there any perfect square in 16? Well, if I don't know right away, I could write it this way. 4 to the second gives me 16, doesn't it? Y to the fourth. Why write it this way? Because I can then take this 2 into this 2, couldn't I?
Yeah.
So what comes out here? 4. Y to the second, correct? Do I have anything in the radical? Nope. Nothing. So I end up with 4y squared. How about I erase this and we do the following problem. What's the index?
15.
It's an implied 2, isn't it? Now, since this is all encased in parentheses, do I worry about this exponent or this exponent?
Yeah, that's good.
I worry about the outside exponent. So this 2 would go into this 2 how many times? Once. So I have out here, the negative stays, parentheses, x squared minus 6 to the first. Do I have anything inside the radical?
Okay.
Since it divided evenly, that's my answer.
You distribute the negative?
I could, if you're saying, could I come up with this?
Yeah.
I could if I wanted to. Yes. So either one of these is correct. Huh? This whole thing is squared, right? So doesn't this 2 go into this 2 once? Into that whole thing, so I end up with x squared minus 6?
What if it doesn't start with 0?
Let's say this was a 3, then I would have had this, then another square root, x squared minus 6 in parentheses to the first.
Okay.
So if I would have had this, x minus 6, I'm just going to make it to the fifth. 2 goes into 5 how many times? Which means outside here I'd have x minus 6, the quantity squared, the square root of x minus 6 to the first. Okay? So what happens if I have this?
We have a problem.
We may have a problem. Yep. Well, the first thing that I would look at is there any number that I can multiply together to get me to 243? And you probably don't know what it is off the top of your head, but take 3 times 3, and what do I get? Times 3, times 3,
243?
but 3 times 27, not quite 243, 81,
Oh,
times another 3,
243.
243. So actually, couldn't this number be written as 3 to the 5th? If I break it down,
Yeah.
right? I just got done. 3 times 3 was 9, times 3 is 27, times 3 is 81, times another 3 is 243.
Yes.
A to the 20th, B to the 25th. Why break it down that way? Because now, isn't it easier to take this 5 into this 5? So 5 goes into this exponent of 5 how many times? So I have a 3 outside the radical. 5 goes into this a to the 20 how many times? So I'd have a to the 4th. 5 goes into this 25 how many times?
5.
Did I have anything left over?
No.
That's simplified. Okay?
Will there ever be a number, like any index with the 5, or?
Yes, it's very possible.